Does the way you own and operate your aircraft affect its reliability? Aircraft reliability is an ownership system outcome. Cancelled flights, diversions, missed appointments, unplanned layovers, and the quiet dread of wondering whether the aircraft will be ready when you need it. Aircraft reliability is not only a maintenance issue. It is shaped by the way the aircraft is selected, equipped, stored, operated, monitored, and maintained over time. Hello, my name is Sebastian, founder of West Aeronautics. We provide aircraft ownership consulting for prospective and early stage owners of Continental and Lycoming powered aircraft. We run the Pilot Owner Accelerator, a structured program that helps aircraft owners become professional operators. If you find these videos useful, hit that subscribe button. And if you have any questions, leave them in the comments below. Now, let's get back to the topic. Declining aircraft reliability is usually noticed only when something happens. A defect is discovered, a component fails, or some form of corrective action becomes necessary. You may experience a cancelled flight, diversion, or maintenance delay as one isolated technical event. Generally speaking, owners notice the symptom rather than the cause. The difficulty is that cause and effect are often separated by time. When an aircraft reliability problem becomes visible, it may not have been caused by the action taken immediately beforehand. It may be the accumulated result of decisions, operating practices, environmental exposure, or ownership habits established months and sometimes years earlier. This delay makes it difficult to connect an eventual reliability problem with the conditions that caused it. A single action may appear insignificant at the time. Repeated often enough, however, the effects can accumulate until the aircraft begins to show symptoms. What owners do see are the reliability problems themselves. Many are discovered during scheduled maintenance, which is one reason why we tend to think of them as maintenance problems. Sometimes they are, but in many cases maintenance is simply where the problem is finally identified. The underlying cause may lie elsewhere in the ownership and operating system. When I started my journey in general aviation, I believed aircraft reliability was influenced mainly by the design of the aircraft, the quality of its systems, and the maintenance performed on it. If the aircraft was well designed and properly maintained, I assumed it should be reliable. Even then, I sometimes worried about the condition and reliability of the aircraft I was about to fly, particularly when renting from a charter company or flying club. I did not always know which systems and processes they had in place, how the aircraft had been operated, or what had happened to it previously. The aircraft may have been technically airworthy, but I had little visibility into the ownership and operating history behind it. When I became head of flight operations, I was surprised by the number of issues we encountered, both during maintenance and in operation. I was determined to do everything by the book, because that appeared to be the safest and most responsible approach. Yet, the reliability of the aircraft did not improve in the way I expected. I also assumed that operating parts and components on condition would reduce reliability and increase the likelihood of failure. That assumption also turned out to be wrong. For almost 2 years, I continued along the default path. We followed the established maintenance approach and even used different maintenance jobs for different aircraft, but without having a significant improvement in reliability or cost effectiveness. To be fair, the default path appeared entirely reasonable. I had been hired as a flight test engineer and was later asked to take responsibility for the company's and customers' aircraft in addition to my primary role. I had not been trained specifically in aircraft ownership, maintenance governance, or reliability-centered maintenance. Working with approved maintenance organizations and following established procedures seemed like the correct thing to do. The problem was not that the maintenance shops were incompetent or that the established processes had no value. The problem was that I was treating reliability as something delivered by the maintenance system. I had not yet understood how strongly it was influenced by the wider ownership and operating system around the aircraft. 3 days before my friend, who was also my supervisor and a test pilot, and I were due to leave for a 9-week flight test program in the United Arab Emirates, he bought a Mooney M20J. We collected the aircraft from the Czech Republic and ferried it to Austria at the last possible moment and in less than ideal weather. The wind was forecast to be too strong for us to make the outbound journey in the touring motor glider we had originally planned, so we drove instead. Eventually, we managed to get the Mooney to its new home base. We opened a beer to celebrate the arrival of the new-to-him aircraft, called it a day, and began preparing to fly to Dubai 2.5 days later. The flight test program was demanding and the working environment was brutal. I distinctly remember the heat and the dead pigeons occasionally falling onto the desks that had been placed in the middle of the massive military hangar. There was not much to do during the weekends. Most of the time we stayed at the accommodation, watched NFL games and occasionally walked along Al Raha beach. My friend used the time to prepare for aircraft ownership. He went down the rabbit hole. He read and watched everything he could find about general aviation, the Mooney M20J, aircraft maintenance, engine operation and aircraft ownership. One morning on the way to the military airbase, he told me about Mike Bush and Aviation and suggested that I look at their work. And that is exactly what I did. Over the following months and years, I studied their approach to aircraft ownership, engine operation, maintenance decision making and reliability center maintenance. Their work challenged several assumptions I had previously accepted without much question. It also led us to develop our own interpretation and practical implementation of those principles within the wider aircraft ownership system. Aviation remains an important benchmark for reliability-centered and predictive maintenance. We also use its specialist services for engine data analysis and bore scope inspection reviews for our customers. The most important change, however, was not simply finding a different maintenance philosophy. It was realizing that aircraft reliability was being influenced continuously, long before the aircraft entered the maintenance job. As it turns out, aircraft reliability is influenced by much more than aircraft design and maintenance. It is heavily influenced by several factors that the owner can affect throughout the entire aircraft ownership life cycle. To be clear, design flaws and maintenance-induced failures will always diminish aircraft reliability. No matter how well the wider ownership system is set up, design flaws and maintenance mistakes cannot simply be corrected through good ownership and operating practices. However, they may be identified before they result in extended ground time or, in the worst case, a serious safety issue. Reliability is therefore not created by one maintenance event or one service provider. It is the result of interaction between aircraft selection, ownership environment, equipment, operation, maintenance and condition monitoring. Aircraft reliability begins before purchase. The aircraft must be appropriate for the planned mission, required payload and range, expected annual utilization, operating environment, runway requirements, weather expectations, available maintenance support and budget. It must also match the pilot owner's capabilities, including licenses, ratings, currency, and proficiency. An unsuitable aircraft may be mechanically sound, but operationally unreliable for the intended mission. An aircraft that is too complex, poorly supported, infrequently flown, or badly matched to the owner's actual use may create frustration even when it is maintained correctly. An aircraft that does not match the intended mission will eventually fail to deliver what the owner expects from it. If a pilot owner intends to use the aircraft for business travel, high dispatch reliability is usually essential. He cannot always wait for the weather to improve. Depending on the mission, this may require an instrument-capable aircraft and pilot, and in some cases even an aircraft approved for flight into known icing conditions. Otherwise, too many trips will have to be cancelled. The aircraft may be mechanically reliable, but it is not reliable for the intended mission. The same applies when the aircraft does not match the performance requirements of the intended destinations. Takeoff, landing, climb, payload and range limitations all affect whether a flight can be completed reliably. If the aircraft and its engine are repeatedly pushed to their practical limits, something will eventually suffer. An engine may or may not reach or exceed TPO when it is consistently operated close to the limits. But the way it is used will influence the probability. On the other hand, an owner cannot expect a reliable aircraft when it sits on the ground most of the time. It's flown only occasionally and no measures are in place to protect it. Corrosion, seal deterioration, battery problems and other inactivity-related issues develop while the aircraft sits on the ground. Operating an aircraft close to its limitation is common practice in general aviation, but it will eventually produce less than desirable consequences. The quality of the maintenance and the capability of the pilot owner also influence how often a flight has to be cancelled. That in turn directly affects dispatch reliability. Once the basic ownership foundation is in place, the ownership environment has a major influence on the aircraft reliability. Storage, operation and support conditions matter. The environment in which the aircraft lives influences the condition in which it flies. Depending on the environmental conditions, several measures should be put in place to improve reliability and protect the aircraft as a long-term asset. Generally speaking, a heated and insulated hangar is one of the best investments a pilot owner can make. It does not only protect the aircraft from wind, precipitation, sunlight and other environmental exposure, it also reduces daily temperature changes, which can cause condensation and subsequent corrosion in the engine, airframe, components and systems. A hangar also makes routine care easier. It facilitates pilot owner maintenance where desired, battery charging, engine preheating, aircraft preservation, inspections and general upkeep. Engine preheating and preservation are two of the most overlooked yet most effective measures for protecting a piston engine and improving long-term reliability. We recommend preheating whenever the engine core temperature is below 0 degrees Celsius. Purpose-built systems from manufacturers such as Tennis and Rife make this relatively simple. They can often be controlled remotely, allowing the owner to switch the system on several hours before the planned flight. Improvised methods such as hair dryers are generally ineffective and not worth the effort. Preheating is not simply about warming the oil externally or blowing warm air into the cowling. The objective is to raise the temperature of the engine core sufficiently before start. We recommend preservation whenever the aircraft will not be operated for more than 30 days. This is one of the most neglected and misunderstood measures in piston aircraft ownership. For some reason, many owners do not understand why an engine should be preserved when it is not being operated regularly. Matters often become worse when ground runs are performed or the propeller is turned by hand instead of preserving the engine properly. A short ground run may introduce moisture and combustion byproducts without bringing the engine and oil system to the temperature required to remove them. Turning the propeller by hand can disturb protective oil films without providing the benefits of proper operation. Engine preservation can be performed as permitted pilot owner maintenance where desired. It requires some time, the correct preservation kit and the appropriate oil and materials, but it is not particularly complicated. In our view, the lack of proper preheating and preservation is one of the main causes of premature piston engine wear, internal corrosion and avoidable teardown. The equipment installed in and used around the aircraft can also make a significant difference. Reliability is influenced by whether the owner has and uses suitable equipment to protect the aircraft and its systems. Preheating systems are one of the clearest examples. A properly installed Tennis or Rife system is one of the simplest, most convenient and most effective ways to preheat an engine when necessary. This measure alone can contribute significantly to reaching TBO and beyond, while reducing long-term wear and cost. The same applies to battery chargers and maintainers. They can extend battery life and help ensure that the battery is fully charged when the aircraft is needed, which directly improves dispatch reliability. Suitable ground handling equipment, plugs, covers, tie-down equipment and chocks can prevent avoidable damage, unforeseen maintenance and repairs. However, one of the most important items of equipment for improving aircraft reliability and safety is a modern engine monitoring unit, ideally combined with accurate fuel flow and fuel totalizing functions. Engine monitors are useful during normal aircraft operation, but their greater value lies in the engine condition monitoring. Engine data analysis, together with oil analysis, oil filter inspection and bore scope inspection, form the backbone of a proper engine condition monitoring program. This information allows the owner and maintenance provider to review the past, monitor the present and make a more informed assessment of what may happen in the future. It can reveal developing problems that would otherwise remain unnoticed until they become more serious. It can also allow the pilot owner to request targeted troubleshooting or a specific maintenance action, rather than reporting a vague symptom and hoping the problem will be found. Instead of simply saying that the engine felt rough, the owner may be able to show when the problem occurred, under which operating conditions, and which parameters changed. This information can also support the operation of suitable engines, parts and components on condition. Aircraft reliability is not only influenced by the measures and equipment put in place, it is also influenced by how the aircraft and its systems are operated. The pilot owner affects reliability from storage and ground handling through startup, taxi, takeoff, climb, cruise, descent, landing, shutdown and securing the aircraft afterwards. This includes parking, tie-down chocks, covers, plugs and locks. Stick and rudder technique influences the loads placed on the airframe, landing gear, brakes, tires and other components. Engine operation has similarly cumulative effects. Poor leaning techniques on the ground and in flight can dramatically affect engine reliability. The same applies to temperature management, power settings, power changes, warm-up and cool-down discipline. Operating excessively rich contributes to lead deposits, spark plug fouling and valve contamination. These conditions can eventually result in sticking valves, detonation, pre-ignition and serious engine damage. Temperature management can also make a major difference, both immediately and over the long term. Cylinder head temperature is one of the critical parameters in piston engine operation and should be taken seriously. Oil temperature, oil pressure, exhaust gas temperature, turbine inlet temperature where applicable, fuel flow and other engine-specific parameters also matters. Proper warm-up and cool-down can make a significant difference, particularly for turbocharged engines. Engine control etiquette directly influences mechanical stress, thermal stress, wear and longevity. Aircraft operation is therefore not only about how well the pilot flies and controls the aircraft, it also includes whether the pilot owner consistently applies the systems, standards and measures discussed earlier. It does not matter how much knowledge or equipment is available if it is not used. Operating techniques and habits compound over time. Repeated decisions influence deposits, fouling, thermal stress, corrosion exposure, fuel efficiency, component wear and engine longevity. Individually, many of these decisions may appear insignificant. Over time, they shape the reliability of the aircraft. Maintenance is of course one of the leading factors influencing aircraft reliability. Apart from avoiding maintenance-induced failures, the way maintenance is planned and performed can improve or reduce reliability significantly. Contrary to popular opinion, operating parts and components on condition can improve aircraft reliability and safety when the condition can be monitored properly or when they form part of a genuinely redundant system. Where a system is redundant, such as certain vacuum pump or generator installations, we may recommend continuing to operate the component until it fails, rather than replacing it at an arbitrary interval. The redundancy makes this possible. Failure of one component should not remove the required system function or immediately create an unacceptable safety condition. This is not the same as operating every component until failure without understanding the consequences. The decision depends on the function of the component, the consequences of failure, the available redundancy, the ability to monitor its condition, and the appropriate response when failure occurs. Maintenance performed strictly by the book also does not always account for the actual operation and condition of a specific aircraft. Manufacturer recommendations are based on assumptions, broad operating conditions, worst-case scenarios, certification considerations, and the information available when the interval was established. In some cases, a fixed interval exists because the manufacturer did not have the resources, evidence, or a suitable monitoring method to determine a more precise condition-based approach. Maintenance should therefore be connected with actual operation and observed condition. Proper aircraft maintenance should include engine condition monitoring. For piston engines, this includes bore scope inspections, oil analysis, oil filter inspection, engine data analysis, maintenance findings, and recurring operational symptoms. It is remarkable how many developing issues can be identified and corrected before they become larger problems, ground the aircraft, or in the worst case, contribute to an incident or accident. Sticking and burned valves, ignition system problems, induction leaks, fuel system problems, abnormal cylinder behavior, and other developing conditions can often be identified before they become major reliability events. No single input provides the complete answer. Together, however, they create a much clearer picture of engine condition. Reliable aircraft ownership does not depend on one inspection, one maintenance program, one operating technique, or one item of equipment. It depends on how the entire ownership system works together. When my friend told me about Mike Bush and Sevi Aviation during our drive to the military base, the conversation was initially about reliability-centered and predictive maintenance. But it became the starting point of a much longer journey that changed the way I thought about general aviation, aircraft ownership, and the wider aviation ecosystem. Over the following years, I spent hundreds of hours reading, listening, learning, practicing, and eventually teaching new methods and approaches. Those ideas gradually became part of my own way of thinking about aircraft ownership and ultimately helped form the basis of Best Aeronautics and the Pilot Owner Accelerator. More recently, while thinking about the structure of the general aviation industry, I arrived at a broader conclusion. The aviation ecosystem is designed to support aircraft ownership, but it's not designed to optimize it from the pilot owner's perspective. Aircraft ownership is supported by many valuable professionals and organizations. Flight instructors, manufacturers, brokers, maintenance organizations, CAMOs, CAOs, aviation authorities, and fellow pilots all play an important role. The challenge is that each is naturally optimized for a different objective. The instructor sees flying, the maintenance organizations sees maintenance, the CAMO or CAO sees compliance, the broker sees the transaction, the manufacturer sees the product. Fellow pilots see their own experience. The pilot owner is the only stakeholder who must see the whole picture. No single stakeholder is responsible for balancing mission requirements, aircraft capability, maintenance operation, reliability, safety, cost, compliance, downtime, and long-term asset value. That responsibility remains with the owner. This led me to 3 recurring mistakes that affect both aircraft ownership and reliability. The first is outsourcing ownership thinking to the aviation ecosystem. The ecosystem provides valuable support, but it is not designed to optimize the whole ownership journey from the pilot owner's perspective. The second is making decisions without a reliable framework. Symptoms, opinions, maintenance recommendations, and isolated data only become useful when they are connected to a mission, operation history, environment, and condition. The third is operating reactively by treating each flight, defect, inspection, and maintenance event as an isolated occurrence rather than as a part of one ownership system. The corrections are equally simple. Think independently, decide systematically, and execute professionally. What changed for me was therefore not simply the discovery of a different maintenance philosophy, it was the realization that aircraft ownership, including aircraft reliability, depends on how the whole ownership system is understood, governed, and operated. Aircraft reliability cannot be improved through one maintenance action alone. It requires a more complete view of how the aircraft is selected, equipped, stored, operated, monitored, and maintained. The good news is that the entire ownership system does not need to be rebuilt at once. You can begin by reviewing 3 areas that have the greatest influence on reliability. First, review the ownership foundation. Start by asking whether the aircraft and the wider ownership setup are genuinely suited for the intended mission. The aircraft should match the required payload, range, runway performance, weather capability, annual utilization, available maintenance support, and your qualifications and proficiency. The ownership environment should also support reliability. This includes suitable hangarage, preheating, preservation, battery care, ground handling equipment, engine monitoring, and access to the right technical support. A mechanical sound aircraft can still be unreliable when it is badly matched to the mission or operated within a weak ownership setup. The single best place to start is to fly the aircraft regularly. Piston aircraft generally deteriorate more from prolonged inactivity than from regular, appropriate use. Regular flying helps circulate oil, bring the engine and systems to proper operating temperatures, maintain battery condition, reveal developing defects, and reduce the likelihood of corrosion becoming established unnoticed. Flying regularly does not replace preservation when the aircraft will remain inactive for more than 30 days. But where regular operation is possible, it is one of the simplest ways to support reliability. Second, improve operational governance. Reliability decisions should not be based on isolated symptoms, assumptions, or whichever opinion sounds most confident. Maintenance recommendations should be considered alongside the aircraft's operational history, engine data, oil analysis, filter findings, bore scope inspections, recurring defects, environmental exposure, and actual usage. This also means defining how maintenance work is governed. The scope, approval limits, diagnostic expectations, and required documentation should be clear before work begins. The objective is not to interfere with the maintenance organization. It is to ensure that maintenance decisions are supported by evidence and connected to the wider ownership system. The single best place to start is to implement engine condition monitoring. Engine data analysis, oil filter inspection, and bore scope inspection create visibility into how the engine is behaving over time. Together, they can reveal developing problems, support more targeted troubleshooting, and reduce the likelihood that maintenance decisions are based only on one inspection, one symptom, or one opinion. Condition monitoring does not predict every failure. It gives you and the maintenance provider better information before deciding what should happen next. Third, establish professional operating standards. The aircraft should be operated according to clear and repeatable standards. This includes preheating, warm-up, mixture management, temperature control, power changes, cool-down, post-flight review, preservation, and the regular examination of condition data. Knowledge and equipment alone do not improve reliability. They only become useful when they are applied consistently. Small operating decisions may appear insignificant during one flight. Over months and years, however, they compound into meaningful differences in wear, corrosion, engine condition, maintenance requirements, and dispatch reliability. The single best place to start is to apply better leaning techniques. At a minimum, the mixture should be leaned aggressively during ground operation. Before takeoff, it should be set as required by the applicable aircraft and engine procedures. In flight, you should understand how mixture, fuel flow, cylinder head temperature, exhaust gas temperature, power setting, and engine configuration interact. The objective is not to follow one generic leaning rule, but to operate your specific engine deliberately rather than relying on inherited habits. Aircraft reliability improves when the ownership foundation, operational governance, and operating standards support one another. Weakness in one area eventually affects the others. Aircraft ownership will never become completely predictable. Some components simply fail. Defects are sometimes missed, and even a well-maintained aircraft can suffer an unexpected technical problem. Professional ownership does not eliminate random failure. It reduces avoidable failure, improves the chances of detecting developing problems earlier, and creates a more disciplined response when something does go wrong. That does not mean that the owner is to blame for every reliability issue. Responsibility is not the same as blame. The point is simply that aircraft selection, storage, equipment, utilization, operating technique, monitoring, and maintenance decisions all influence the conditions in which reliability problems develop or remain unnoticed. Manufacturer guidance remains an essential baseline, but it cannot account for every aircraft's actual condition, mission operating environment, utilization, installed equipment, maintenance history, and ownership circumstances. The owner has to connect the published guidance with the life the aircraft actually leads. This does also not mean aircraft ownership should become a full-time technical job. The objective is not to manage every detail personally. It is to establish the right standards, tools, systems, and specialist relationship so that reliability does not depend on constant improvisation. A good ownership system should reduce mental load, not increase it. What changed my thinking was not simply the discovery that maintenance could be approached differently. It was the realization that aircraft reliability is being shaped continuously. The aircraft chosen, the way it is stored, the equipment installed, the way it is preheated, operated, leaned, cooled, monitored, and maintained all contribute to the eventual outcome. So do the way defects are investigated, maintenance decisions are authorized, and lessons are carried forward. No single decision guarantees reliability, but the accumulated quality of those decisions changes the probability, predictability, and consequences of technical problems. Knowledge matters because it allows the owner to act, but that action must extend beyond monitoring. It must influence how the aircraft is owned, operated, and maintained. The shift is from hoping the aircraft will remain reliable to deliberately creating the conditions that support reliability. Aircraft reliability is not something you either have or do not have. It is something you influence through the way you own, operate, monitor, and maintain the aircraft. The opposite of reliability anxiety is not certainty. It is an ownership system that gives you greater visibility, influence, and informed control. Aircraft reliability is influenced long before the aircraft enters the maintenance shop. It begins with aircraft selection, ownership setup, storage, equipment, operating technique, condition monitoring, and the way maintenance decisions are governed. In our aircraft ownership workshops, we explore how these elements interact and how pilot owners can create a more structured approach to aircraft reliability. The purpose is not to promise that nothing will fail. It is to help you understand where you have influence, reduce avoidable uncertainty, identify developing problems earlier, and operate the aircraft with greater confidence. If this resonates with you and you would like to become a more informed, capable, and independent aircraft owner, we run regular aircraft ownership workshops where we explore aircraft ownership, maintenance, engine operation, and evidence-based decision making. You can find more information through the link below. Remember, the goal is to become an informed aircraft owner. Thank you for watching. I'm Sebastian with Aeronautics, and I'll see you in the next one.